So we hit a important milestone on our work with Spear of the Air. We were able to install a suite of sensors into a wine facility where they're about getting ready to start bringing in the fruit, fill up the tanks, and getting ready to start their fermentation process. So that was a big deadline for us. Big fluctuations on when the fruit is coming in based on the weather, and so really rushed to try and get this installed and verified, validated before the fermentation process started, so that we could gather all the emissions data coming out of the fermentation tanks. So I'm just going to walk through some of the major forks and decisions that we made on this extremely accelerated timeline to try and get this sensor box that we call Spike, try and get this sensor box installed and ready for the fermentation. Okay, now we had essentially two scenarios. One is a carbon capture process with elevated pressures approximately or up to 8 bar. And so essentially we have high pressure vessel, inlet, outlet, and then, well, I'll get back to how we decided to measure there. So then in the short term, we had this pilot project with a potential customer that would allow us to look at emissions, so CO2 emissions. And in this scenario, we have a wine tank with CO2 emissions mostly, and it turns out the emissions here are about 95%, which match up with at an elevated pressure of about 8 bar. We're also looking at 95% CO2 in CO2 concentration. And so in this situation, what we decided to do is, instead of designing a super high pressure, due to limited resources, instead of designing a super high pressure capable sensor box enclosure, we decided to do a bypass line from this high pressure process, and then just keep this to within 1 to 1.2 bar. And so that was kind of our target pressure range. It would allow us to use commercially available off-the-shelf sensors, and just get us up and running a lot faster to be able to meet the deadline for this harvest this year, and be able to attach the sensor box here for this season, and be able to collect data and quantify the emissions of this wine fermentation process. Now, it turned out by the time we got the go-ahead to accelerate the project, a lot of the milling work that I needed for the enclosure had already been done on this Tomac behind me. So then it was just a matter of finishing a lot of the details around the fittings. We used NPT fittings for this, and just O-ring glue using pipe time to keep everything closed. Turns out it's kind of hard to find something that'll maintain elevated pressure. Also, sensors beyond 1.7 bar are hard to find pressure, on a limited time scale. Obviously, there are things you can get to measure much higher than that, but inexpensive, quick to ship. So we ended up going with this custom enclosure, and we're just going to allow us a lot more flexibility for any future updates or modifications to the enclosure. And so, yeah, the Tomac here allows us to get that finalized, and we're ready to assemble the sensors. Now, for reasons outside of our control, we had a 10-day timeline. Now, luckily, we had a lot of the hardware had arrived. So hardware, raw stock, sensors. We didn't have a flow meter, no flow meter, and no backups. So we needed to make sure that we had already this verified the sensors were working, but we didn't have lead time for anything new, essentially. So primary objective was, measure CO2 gas concentration. Now, to do that, based on where this facility where we're operating is, there's this large wine tank enclosure on top, and then we have our essentially our access here. During the fermentation process, we'll capture the data. But it's an operational facility, very large scale facility, and this is off the ground. Call it 10 feet, and they're just catwalks for people to walk on. And so there's personnel there hosing things down. We wanted to make sure that our sensor box here didn't get exposed to essentially hose spray. And so looking at a minimum of IP65 or better to prevent the sensor box from, or the sensors from completely malfunctioning. So that meant that we needed to complete this aluminum enclosure. If we could collect CO2 gas concentration, we'd want to quantify what the emissions are with this flow meter. And then it became a matter of, okay, well, let's just make sure we're collecting data. And so then it was SD card based on a Raspberry Pi, validated that we could collect the data. And then, okay, well, can we access this remotely? So what should have taken a few months of work and prep time, fortunately came down to 10 days. And this is kind of how we essentially prioritized the bare bones system. Is let's protect it from water. Well, first of all, let's collect CO2 gas concentration. Let's protect it from water exposure from a hose, for example. Let's quantify the flow rate so that we can actually make use of the emissions that are coming out of this thing. Provide some value. Let's make sure we can collect the data. Beyond collecting the data over this 1 to 2 week time span, can we access the data remotely? One, to capture any malfunctioning in the sensors, but two, to be able to look at the data in real time and just monitor, essentially demonstrate that we can monitor the process in real time. So that was our, we have 10 days to get this thing going. How do we prioritize to make sure that we can provide some value and demonstrate the emissions quantification for this particular project? Then came the time to install the whole system, and that involved combining. We had a preconditioned filter on the flow system, essentially remove any remove any moisture out of the air so that we could avoid condensation. We had the pi and the flow meter encased in an IP6 enclosure, and then the flow gets routed into our sensor box and then gets exhausted out into atmosphere, which is typically what happens in this facility. We're just going through the sweet stage before it gets exhausted. And so we were able to install a sensor, and this is just me connecting to the system remotely from trying to make sure that we can validate that data is being collected. And really, the only thing we needed was power for the system and power for a hotspot that we ended up using to be able to connect to it remotely. And once we installed it, then we were able to create a simple dashboard that essentially tracks the data coming from the sensors from when we first installed it. There's a few days worth of data here. Um, the CO2 sensor, as a reminder, captures ppm levels from 0 to 100, and so this dashboard essentially just allows us to be able to monitor the process in real time. And so we have all the different sensors here, a couple of them on flow rates, pressures, temperatures for the pie to make sure it's not overheating, and then just ambient temperature and relative humidity. So if you need any help with establishing some remote sensing capabilities, specifically for CO2 or methane, please reach out and we'd be happy to help.